it? Yeah. Yeah, actually, usually for my private lessons, the mother or father, I usually get like a bottle of wine. It's okay, you know. But I don't drink much, so chocolates would be better. I think she got a better deal. Alright, so what we're going to have a look now at is limits. Limits, yeah. Well, it builds on the last topic, so it's not completely new. This sequence here, 1 plus 2 plus 4 plus 8, what type of sequence is this? Is it arithmetic or geometric? Geometric. Because what are we multiplying by? We're multiplying by 2. True? Yeah. So we call this geometric. Now if I continue to add forever, what answer will I get if I do this forever? Infinity. But this is not always the case. If you look here, if I do 1 plus a half plus a quarter plus an 8, this sequence is also geometric, but the OR is what? Who can see the OR? 1 over 2, yeah. Now this is actually not infinity. This is actually equal to, I wonder if anyone knows this one. Yeah, to what though? You're right, it's convergent. Convergent to what? 2. Yeah. So think about it like this. Here is 1 plus a half plus a quarter plus an 8, etc. In total, if you do this forever, you get 2. So let's see exactly why that is. Can I scroll down? So if you have something like this, 1 plus a half plus a quarter, etc. What's the A? 1. What's the OR? 1 over 2. And the N? Infinity. True? The N is infinity. Now let's calculate the sum. What's the formula? It's A 1 minus OR over 1 minus OR, sorry, with an N. So that's 1 minus 0.5 power infinity over 1 minus 0.5. So we really want to look at what the heck is happening here. So if you have your calculator, can you type in 0.5 squared? Type it in, 0.5 squared. Yeah, I'll leave this here for a moment. 0.5 squared. Okay. What do you get? 1/4. A quarter. Now do 0.5 power 10. What do you get? 1/1000. Yes. Now do 0.5 power 100. What's happening? As the power gets bigger, what's happening to your answer? What's happening to it? It's getting smaller. So logically, if you could do 0.5 power infinity, what do you think that number should be? Smaller, smaller, smaller until 0. Yeah? So what I'm saying is that blue piece should be 0. Now, what happens if you did 2 power infinity? What would you get? Type it in. Type in 2 power a big number. 2 power 1,000. Or 2 power 100.
Not 0.
Yeah, it's really, really big, isn't it?
Yeah.
So why? Somebody tell me. Why does this get smaller? Why does it not get bigger?
Because it's negative.
No, it's positive, 0.5. Yeah, so why, what do you mean? Explain more. What? Go on.
The point
Yes.
is has more zero.
Good, yes.
Do you understand?
I understand. Maybe they don't understand.
Did you get my idea?
I got your idea. Did you get my idea? No, so you have to explain more.
I give up.
Okay, that's fine. She's right. It's because of the point, the 0 point. Because this number is smaller than 1, when you have 0 points and you have a power, it makes more zeros. So this will become 0.25 and then 0.0125. It's getting smaller. Okay. So if this piece is 0, what do I get in total? It'll be 1 over 0.5, which is 2. And that's what I said the answer is. So basically, can I scroll down? Yeah, what I need to. Oh, quick. Yeah? So let me give you the result as a sentence here. So look, suppose you have this, sum infinity equals a plus a or squared plus a or cubed, etc. If or is between -1 and 1, then f infinity is equal to a over 1 minus or. And we say it converges. If, or maybe I should just say else f infinity equals plus or minus infinity, and we say it diverges. So if you want this to converge, your or needs to be between -1 and 1, like in my last example. If it's not, then it diverges. So for example, if I keep doing this, what's the answer? Yeah, it's infinity because it diverges. Now what about this one? I want everybody to try this one for me. This one here, calculate it please. What did you get? No, this will converge because the or is, what's the or here? 1 over 3. So it will converge because the or is 1 over 3. This will be 1 over 1 minus 1 over 3, which is 1 over 2 over 3, which is 3 over 2. So this one here converges. Now, to help you here a little bit, let me open up a program here to help. Yes? Can I show you something here on the program? Yeah? Oh, it's loading. So look, if the or is between -1 and 1, does it converge or diverge? Converge. And if the or is not between -1 and 1, it diverges. So here, look, the or is equal to 3. So this means it diverges. And here, what does the or equal? In this one? 1 over 3, so that means it converges. So you have an answer here, but you don't have an answer here. Yeah? So let me show you this in the program. So look, here is n. So we'll go 1, 2, 3, 4, 5, 6, 7. And then here's u. So what was it? 1, and then we multiply by 3. Now I can't go to infinity. How far would you like me to go? I think 10,000 might be too much. Shall we say 100 maybe? 100's pretty close to infinity.
300.
Fine. So 300. Okay, and then we'll go all the way down. Yes, actually it is 299. And then here, that's u, and then here's my sum. So this one here will be 1, and then this one here will be 1 plus 3, and then this one here will be all of these added together. So 1 plus 3 plus 9 is 13. So if I go all the way down to so look, it's the heck? Oh, whatever. That's fine. So if we look, this is a huge number, a power of 142. Now what about if I do instead the other sequence where it's 1 plus 1 over 3? So this would be the last one divided by 3, so 0.33. If I go all the way down, look at that, 1.5. Say what? So you can see it actually gets to 1.5 pretty quick, like after only 21 terms. Excel says it's at 1.5 because there's too many 9s. See that there? Yep. So this is convergent. So for the first question, if I give you a sequence like this, 3 minus 3 over 2 plus 3 over 4, and I ask you plus ... converge or diverge, you need to calculate the OR. So OR equals minus 3 over 2 over 3, which equals minus a half. So converge or diverge? Which is it? Converge or diverge? Correct, convergent. And actually you get these questions in the exam, but because they're so short, they're only 1-mark questions. But you do get them in the exam. Okay, next question now. Can I scroll down?
Yeah.
Yep. So let's have a look at this sequence. What I would like everybody to do for me is to give me the first 4 terms. And I tell you to start with 2. Give me the first 4 terms. What do you need, Claire? You got something? Your pen? Sorry? Okay, did you write this down? Yes? Okay, so give me calculator, give me the first 4 terms. Calculator? Grace, you got your calculator? Let's get it out. Hang on. What do I tell you to start with? 2. So what's the next term? You have it, Fahad? What is it? Yeah, the decimal it's 2.5, yeah? And what's the, no, the decimal?
2.8. No?
Yep. Keep going, what's the next one?
2.928.
Yep. And then what's the next one?
2.9756.
Yeah? You remember, we did these last week. What are the names of these sequences? What are these sequences called? Nobody ever remembers. Begins with an or. No. Recursive. Remember this?
Yeah.
So look, if I go all the way to 100, what do I get? 3. So what type of sequence is this? Convergent or divergent? Convergent. Converges pretty quickly to 3. Yep. Now the problem is, how do we calculate this? How do we calculate the answer? How do we calculate the limit t infinity? In other words, my question is, what does it converge to? Now, of course, on my computer and on your calculator, you can just, do it like this. But the problem is, what if it's not a nice number like 3? What if it's some number like 1.42613? You need some way to calculate it exactly, and that's what we're going to do now. So let's have a look here. Now what I want you to notice is, look, this is T13, this is T14.
Yeah.
Are they similar or very different? Similar. And what about T18 and T19?
That's same.
The same. So in other words, the further you go down, the more similar the neighbours will be. So the logic goes that when n is very large, Tn will be about the same as Tn minus 1. There's not going to be much of a difference. We all agree?
Very large.
Yeah, if we go back here, so Karar, is there any difference between T99 and T100? No. And what about at the start? Is there much of a difference between T1 and T2? A little difference, yeah. So my point is, when it's very big, the n, the difference between the neighbours is very, very, very small. So what I'm saying is, when n is very large, like infinity, the difference here will be so small we can say they're the same. So what I'll do is I'll call this x and put that back in here. So now you can make this x equals 4 minus 3 over x. You see what I did? I replaced this and this with x. Now how can I solve this? How can I solve this?
Yeah.
Any idea? Yeah, what should I do next here? Look. What should I do here? Here, Grace, look. What should I do next for this? How can I continue? What should I do? What's next? Yeah? Yeah, but how do I simplify? What do I do?
This side.
Yeah, something else though. Multiply by x. So then you get x squared equals 4x minus 3. Now what type of problem is this now? Quadratic, isn't it? And what are the solutions? X equals, x minus, and x minus, is it? Yeah. 3 and 1. So what is the x here?
3 or
1 or 3. Now we have two answers, but we know which is the right answer. Which is it? Which answer was the correct answer?
3.
It was the 3, wasn't it? So we have now the limit is exactly 3. Now some people might say, so what happens with the 1? Why don't you use the 1? Well, there can only be one answer. But sometimes 1 is the answer. Can I go back to my program? Yeah. So what happens if I start at a different number? Everybody look up. So, for example, if I start at 5, what's the limit here? It's still 3, isn't it? If I start at 10, what's the limit? Still 3. My point is, for the limit, you don't really care where you start. You only care where you end. But sometimes you can make a different limit. Let's see, if I start at 1, if I start at 0.5, no, I still got the 3. Alright, I want to try and get to 1. Let's see. No. No, I want the same formula. I can't seem to get to 1. Unless I start at 1. No. Oh no, 0 will be very bad. See?
0.1.
No, you see, it looks like, oh, I'm going to get to 1. No, 3.
0.1.
0.1? Give it a try. No, still get to 3. So, yeah, I can't seem to get to 1. Now you have 2 answers, and sometimes both answers could work. But as you can see in this example, it seems very difficult to get to 1. What does the sequence always want to try and get to? 3. Now you might say, in the exam, which answer do I pick? Well, what you need to do in the exam is you need to make the first few terms. So imagine in the exam, your calculator said these were the first 5 numbers. So if you had a choice, if I said the limit is 1 or the limit is 3, which one do you think it must be? Well, it must be 3, because look at what's happening. Yeah. So you make a judgment. You look and you think, okay, I think this is moving to 3 and not 1. Yeah. Can I get to 1? What about if I try a really, really big number? No. No.
After love,
The discussions come on the exam?
Oh yes, it is, yeah. Can't get to 1, that's sad. It seems like I can only get to 1 if I start at 1. Yeah. Anyway, this is actually a pretty common question on the exam. And the way to calculate the limit, all you do is you replace this and you replace this with x, and then you solve. So it's not too difficult. Yeah. And sometimes you have to use the formula here. Sometimes the answer is like this. Yeah. You know what I mean? The quadratic formula. Yeah. Okay, next one. Something like this. Tn equals minus 5n squared plus 8n plus 5 over minus 4n squared plus 2n. Okay, so what's the first term here? That would be minus, let me see, 5 plus 8 plus 5 over minus 4 plus 2, which is minus 18 over minus 2. So the first term is 9. Do you see what I did? I just replaced n with 1.
Why did you put minus?
The minus is in the front, yeah. Yeah?
Okay.
Now, you might say, okay, what happens if n equals infinity? Well, let's see what we get. Minus 5 infinity squared plus 8 infinity plus 5 over minus 4 infinity squared plus 2 infinity. What the heck is that? So this doesn't work. We need to try it a different way. So what we do here, you look and see what is the biggest n you have. It's an n squared. You see that?
Yeah.
And we divide the top and the bottom by n squared. So now we get Tn equals minus 5 plus 8 over n plus 5 over n squared over minus 4 plus 2 over n. Yeah?
If you want the infinity, we just need to divide.
I divide everything by n squared first. Next, yeah? I divided every term by n squared. Now let me put infinity in. Five plus 8 over infinity plus 5 over infinity squared minus 4 plus 2 over infinity. Like this. Now, can I go to the side?
No.
I'll go back, don't worry. If I have a small number over a very large number, what answer will I get? Big or small?
Small.
Very small. True?
Yeah.
So what about instead of very large I have infinity? What will I get here? Zero. Very good. So that's the point. This is 0, this is 0, this is 0, and you're left with 5 over 4. And this is the limit. Yeah? Question?
No.
Why 0? So if you have your calculator, like here, like 8, if I do 8 divided by a big number, it's very, very small. So this is infinity, so it's so big, this will become 0. This will become 0, this will become 0. Only these will stay. Is that your question? Yeah, is it okay? Are you sure? No, okay.
That's minus 4.
Yes, minus 5 over minus 4. Yeah? Can I go to another page?
Yes.
Yeah?
No.
Oh, come on. You have a question, Miranda?
I don't understand.
Do you want another example?
Yes.
Of this one? Let's do another one. I'll do a smaller one. Look. Suppose I have Tn equals 1 plus 2n over 3 plus 4n. Okay. What is the first term? That would be, Amanda, what's the first term here? It would be 3 over 7. Yeah, and then the second term would be what? Amanda? No, I won't pick on Amanda. Grace, what's the next term? N is 2.
5 over 7.
Very good. Okay. Now, let me go to my program here. Look. Here is n, and here is Tn. N is 1, 1 plus 1. Okay, there. So it is, what did I say? 1 plus 2n over 3 plus 4n. So what did you say the first term was, Amanda? 3 over 7. So that's name error. That's 3 over 7. And then what did you say the second term was, Grace? 5 over 11, wasn't it? There's 5 over 11. So what's the limit? Let's see. Let's go very far down. So what does it look like the limit is here? What do you think?
5?
No, not 5. Let's keep going.
0.5.
0.5 maybe, we think. But it's not quite reaching it, is it? It's going very slowly there. Let's go some more. Let's go to 1,000. Boom. We're getting closer. So let's go back here. My trick is the biggest n is n. So I divide the top and I divide the bottom by n. So now I get Tn equals 1 over n plus 2 over 3 over n plus 4. Now, I make n go all the way to infinity. Yeah?
Last one and square root, now you separate.
No, there's no n squared here. It's only n. I use the biggest n.
Oh.
Yeah. So here, Grace, if I have 1 over infinity plus 2 over 3 over infinity plus 4, what do you think that is equal to?
4,
Say again? Correct, yeah, because this goes, they're both 0, and this is equal to 2 over 4, which is 1 over 2, which is 0.5, which should not surprise you, because that's what it looks like it's trying to reach. It's trying to reach 0.5, we think. So this is the limit. The limit is 0.5.
Won't go almost to
I don't think it will go over. I think it's always trying to reach it from underneath, like a sealer. Now what we'll do is, I'll give you some homework from this, but the last question I'll do in the next class. Okay? So you just need to do 1, 2, 3. And what I'd like you to do, you can do BC, BC, BC in 1, 2, 3. Do you get that? 1, 2, 3, BC, BC, BC. Yeah. Now, for us, we don't use this type of language. It's not on the course. It's more informal. This is more, we are looking at limits in a very informal way, you know what I mean? This is a very formal way of doing it. So you will do this next year at university. Or some people study in high school. It's not on our course. Okay, we're finished.